will tell you about the project Smart Block today. It was funded by the Climate Fund in the first place, but now it's continued in the CEFIPA project. So this is why there is no special Smart Block logo or something like this here, but the CEFIPA logo. And CEFIPA aims to contribute sustainable energy and energy efficiency through innovative financing systems. So this is why in Smart Block we had a contracting system. So what is the approach of Smart Block? We all know that we have the problem that there is not enough refurbishment rate, especially in Vienna and in Austria. So Smart Block tried to raise the refurbishment rate by looking at building blocks instead of just single buildings, just to see if there are synergies that can be used and when looking at the building block. So and we did this also by using really participative methods. So we spoke with the tenants, we spoke with the owners, brought them together, made workshops so that they can really be enabled and see what they can do, if they can do something. So, and what came out from this approach, from speaking with the owners and the tenants, is we saw that in the block we looked at, it is possible to use deep drillings as a seasonal heat storage by using hybrid solar collectors. We can regenerate the deep drilling holes in the summer, so we get a really high seasonal performance factor of about or over 6. And the next thing is that the organizational solution was that those deep drilling holes are not only used for a single building, but for more buildings in the block. So you can also use synergies again. So and there is economy of scale, so things get cheaper because you can make more holes when you look at the whole block. And then the economic solution was that we used a contractor to break up the tenant and owner dilemma. So I guess most of you know this one, so I'm not going into detail here. And so what is the block we were looking at? Some of you might know it when they live in Vienna and are into bike sports, because this is a really famous bike store here. It's Norasport. So this is why I always remember where it is. We started with 2 buildings where the owners said they want to refurbish their homes, and they are starting spring 2018, so now, but maybe it doesn't look like spring, but it is. Then there is a phase 2 where 4 additional buildings are getting refurbished, and then use the drillings from the phase 1. So basically it is a high investment but low energy costs when it comes to a solution like this. But when you look at the full costs over 20 years of lifespan, it's cheaper than district heating, for example, and it saves about, from our calculation, about 85% of energy. So this is the block again. So here we have the 2 buildings that we start with, and here you can see here is where the drillings are done in the courtyard, and then there is another building here that gets teared down, also in the near future. So here we have some more space for drilling. So the building gets teared down, you drill a lot of holes in there to have enough drillings for the other buildings that come up here. And so in this way we can make an energy grid, not energy but Energie in German. It sounds really similar. It's really hard to distinguish. And so we're able to use also the solar panels that are on these buildings to restore the drillings and the heat in the drillings for all the buildings. So this is another thing we can do and use as a synergy in this project. So it is really, there is a lot of details you have to look at to get the whole picture, but then you have a lot of synergies you can use. Also, there is another building here that is already using deep drillings as a heat source and heat pumps. So this is also going into our energy grid, so that we have enough drillings to even get more buildings than the one that are coming in the next 2 years. So maybe the block is nearly can nearly be sorry. So we can get some more buildings into the grid. So to say. So just looking at the costs. Just a quick overview. These are the costs over 20 years, but per year in square meters. So we can see the natural gas solution with solar heat and central heating system is the cheapest one, but there is not much difference when you look at the whole lifetime between our system and the gas-fired system. So, and what is really interesting is that the district heating is much more expensive than our system. At least when you take into account the subsidy of the city of Vienna. So here is again where contracting comes in. Normally the landlord would say, okay, I have to pay this, just that the tenant is having low energy costs, so the contractor says, okay, I will do the investment for the whole thing and pre-finance it, and then the tenant pays like nearly the same as this amount, and the landlord is happy to doesn't have to invest so much. So what does this all have to do with sector coupling? We are able to use demand-side management by using the thermal mass of the buildings, because those buildings have a lot of thermal mass. They're from the 19th century, so it's concrete, big concrete walls, and therefore it is possible to really save a lot of energy in the walls and the whole building, and then be flexible. Like we also have the IEA annex of the flexible buildings we will hear about later from Susanne Metzger. She comes after me, I think. She will tell us more about this one. And also what we're doing in this project is we use a flexible electricity tariff to save costs and also relieve the electricity grid. We do this, you can see this here. This is the electricity costs for 12 days in February. So you can see there is a wide span of what electricity costs over the days. This is hourly prices, and because we have so much thermal mass, we can say, okay, we only have to heat I don't know, 5 hours a day, so we pick the cheapest 5 hours. And those are also the hours where there's a lot of electricity in the grid and where there's not much demand. So this is a really easy approach, but has we we can get 2 flies with 1 clap, so we save money and we relieve the electricity grid. So, but what is the really great thing about this project is that we have a test bed here that can be used or multiplied in the whole of Vienna probably, because there are a lot of blocks like the block we had looked at. And so we can see just now as a short overview, there is a building that has solar thermal space, and there can be deep drillings here. So this building uses the energy from here, and so you can just switch and use the synergy, and this can be multiplied maybe 1,000 times in Vienna. So that's a great thing. Thank you.